Hey, I'm Nick, and this is going to be the first video in what'll hopefully be a series of videos about building an off-grid cabin for myself. So like a lot of other people over the last couple of years, decided that that was something I wanted to do. Thinking back to my childhood is probably a lifelong dream. And so I bought a piece of land and started thinking about what I want to do with it. So this video I'll talk a little bit about how I designed it and kind of my thoughts on that. It's not meant to be a be-all, end-all about designing an off-grid cabin. I'm not an architect, not a designer, not a engineer, not a solar expert. There are a lot of things I'm not, but I do have a background in construction and have done some design. And so, maybe people will find this interesting or useful. You know, it's all personal opinion. It's all for me. I'm sure that, there'll be a lot of thoughts about different ways you can do things, or maybe I'm wrong about something, or whatever the case. But hey, it's for me. No one's going to get hurt doing this except me. It's my own choices, and so let the chips fall where they may as far as the internet is concerned. So most design books, good design books, I think, talk, when you're thinking about structural design or architectural design, talk about the site. And so first thing I'll talk about is the site, because I don't think you can really have a great design or an interesting design until you've stood out where you want to put the building and see where the sun rises, the sun sets, where the views are, where the wind blows from, and just all the things that go into it. So here we go. So this is the site, and of course you got to use a little bit of imagination because there's a lot of underbrush and trees in the way. But we're looking basically southwest. And so here you see that the view on this site is really going to be to the south and to the west. And it should be pretty cool once everything's trimmed back and some of the underbrush is cleared. My goal is to build the cabin on about a $15,000 budget. So the design is geared towards that, trying to be as efficient as possible. So early on in the design, one of the things that I decided was that I wanted cabin to be about 16 feet by 16 feet. And I'm trying to keep it under 400 square feet total, because the area that I live in has what they call a recreational cabin law that exempts structures under 400 square feet from certain requirements, as long as it's not a year-round residence and you don't use it for business. So having decided that it'll probably be roughly 16 feet by 16 feet, I started thinking about what kind of a roof would I want to put on it? What's the sort of overall outside shape? And so I first started designing it with a simple shed roof, just a traditional design, very simple, easy to build, quick. But one of the things I decided about that was that because I want to do totally off grid, or have to do totally off grid in solar, I'd like the roof to be at a steeper angle than I might otherwise build it. So roughly like a 40 to 45 degree angle. And that might not be optimal for solar in the summer, but it will help get a little bit better solar gain in the fall, spring, and winter. So when I looked at this design, the challenge here is that if you have roughly an 8-foot wall, and let's just say for simplicity of calculation, 45 degree roof at 12-12 pitch, you're going to end up with about a 24-foot high sidewall here, which is something that I didn't want for a variety of reasons, both aesthetic as well as practical. So although I didn't throw away that idea, I thought about exploring some other options. So I then considered, probably one of the most traditional roof styles in this area of the country, which is a gable roof. Also relatively simple to build, and would make it a little easier. So if I had about a 12-12 pitch, again, about a 45 degree, or not about a 45 degree roof, that would then make this height here 16 feet, which is a little bit more aesthetically pleasing, and also just from a construction standpoint, a little bit more realistic. However, just being honest, my own personal taste, I decided that I wanted something a little bit more contemporary than a gable roof. And that's not a judgment on gable roofs or anything. It's just a personal choice. So I then started looking at different approaches that would both get me the portion of the roof that with a steeper pitch to mount the solar panels on, as well as something that's a little bit more of a contemporary design that would be more appealing to me. So I came up with something, and I thought it through. I did some initial sketches and kind of proof of concept, and then I did a more refined sketch to see if I liked the idea. So I dusted off my grandfather's antique drawing table, which is a super cool old cast iron device, which my cat is rubbing her face on. And I also dusted off my sketching skills, which are pretty rusty. And I did a concept sketch of a little bit more of a contemporary design that has a 10 pitch roof facing to the south for solar gain, and a less steep shed roof on the northern side with some clear story windows, and I like it. So I decided that I would move forward with this as the idea for the design. So hey, before I move into the next part, I just want to say I tried to keep it short, but it's hard to talk through all these things. It's going to be mostly screenshots or captures of my computer screen, so maybe a little bit boring as I talk through it, but I tried to keep it interesting. Also, the audio quality is not as ideal, but if I make $1 million and get famous on YouTube, then I'll go out and buy some audio equipment and try to do a little bit better job of recording. But anyway, I hope you find it interesting. Thanks. A little bit more about the dimensions. As I mentioned earlier, I decided to go with about a 16 foot by 16 foot overall footprint for the cabin. Specifically, I designed it so that the framing or the actual footprint of the framing is 1 inch less than 16 feet. Reason for that is I'm trying to maximize the use of the sheet goods that I'm going to be using to build this. And so by keeping it to 1 inch under 16 feet, the floor sheathings will all fit with a little trimming, with very little waste, and the wall sheathing will fit exactly to 16 feet because there'll be about a half-inch overhang on each side. So I'll use exactly the full size of the panels, so almost no waste there. And of course, when you're designing, there's a lot of factors that you have to consider. Some are aesthetic, some are practical. In this case, I am going to use T111 sheathing as both the structural sheathing for the cabin, but also as the exterior. And T111 might not be the most beautiful product in the world, but as I also mentioned earlier, I'm trying to do this on a budget. And so, it is a cheap, relatively speaking, fairly durable product that looks okay if you can work with it, some of the details on it. And it's durable, and it is both the exterior as well as the structural sheathing. So it saves some effort from that perspective. So again, that kind of brings you back to the whole idea of a 16 foot by 16 foot, making sure that I'm going to use the full width of those panels. Also, it keeps the framing lumber down to a 16 foot dimension, which is what's commonly available. Gives me a chance to cut just a little bit off of it, so that I'm making sure that all the pieces are the right length. So we'll talk a lot more about other dimensions, but that's the kind of was the overall thought process behind that 16 foot by 16 foot footprint. So talking a little bit about the roof again, I designed it so that this design has about a 10-12 pitch on the south-facing side of the roof. So that is where the solar panels will be mounted. And, yes, I'm aware that there are other choices that can be made with the solar panels, but this is the choice that I made. On the northern half of the building, there is a shed roof, which has a 412 pitch, which is about as low as you really want to go with conventional shingles, which is what I'll be using, architectural fiberglass or asphalt shingles. And that also provides, a fair amount of height underneath the roof for the loft, which is part of the design as well. So the rafters on the north side on the shed roof will be longer than 16 feet because of the slope and also because of the overhang, but they'll be under 20 feet, and 20 foot is a dimension that you can get 2x10 lumber in. It's usually probably going to be a special order, but it's doable, or I can split them in half and put a beam underneath them, which I'm going to probably not do for reasons I'll talk about later. So, one of the things to talk about with the roof is overhang. So I made this with a fairly deep overhang, which is about 16 inches on both the eaves as well as the soffit side. So, and overhangs, generally speaking, with roofs are good things. So in this specific case, it helps keep rain and snow off the exterior and off the windows and things like that, which reduces some of the wear and tear on those items. And then it also provides a little bit of shade. So, hot summer day, when the sun is directly overhead, it'll cast a little bit of shade over the windows and such, which is advantageous for not making the inside too hot. There's not going to be any air conditioning. And then also, but allows the sun in when it's at a lower angle in the winter and later in the afternoon, which does, help warm it up in the cooler months. So the orientation, as I mentioned before, so this is we're now looking at the south side. So facing south towards the sun, where the solar panels will go. This is also going to be the entrance. So down here in this corner is going to be a patio or a French door for the entrance to the cabin. Not too many windows, one window, south facing. If you have too much glass there, it's going to get kind of hot. But it does face out towards the view, or part of the view that looks out into the valley. The west side of the cabin, this is really where I think the main view is going to be. It looks out over the valley, so that's where I've got the majority of the windows, and I think it'll be really cool in the evening as the sun is setting to have that, high windows and the view looking out. Not too much heat gain in the summer, but just should be beautiful. On the north side, so I'm going to have clear story windows where these two roofs meet. And I think that's going to be, northern light is always very cool. It's kind of a soft light, and it will come in through the north clear story window. It'll hit the ceiling, and it'll reflect down into the room, which I think will be a really nice effect. There are two windows also on the north. One will be in what is probably going to be the sort of bathroom area on the first floor, and the other will be in the loft where I plan to have a bed. The rest of the north wall will be sheathed, and there'll probably be bookshelves or something like that on the inside. Facing to the east, so there's one window over what will probably be on the first floor, over probably what will be the kitchen sink, and then there's again going to be some high clear story windows facing east. And what I'm hoping that will do is capture some of that early morning sun when the sun first pokes its head above the mountain. And again, hopefully that light will come in here and reflect off the ceiling and bounce down into the room. I think it'll be a really interesting effect. So we'll see how that all works out once it's all built. So that's talking a bit about the orientations, the roof, and the windows. I do want to add, so one other factor that I took into consideration here is that, again, totally off-grid, I'll have a cistern and I'll be collecting water. I looked at one really cool design that I saw on Instagram. I thought it was a super cool roof design, very inspirational, but it would have made collecting the water off the roof very difficult because it didn't have eaves where gutters could be mounted to collect that water. So I had to sort of leave that design aside, even though I thought it was really cool, and settle with this design, slightly more conventional, which I'll be able to have a gutter along the south and along the west wall, which will capture that water coming off the roof and pipe it into a cistern. Taking a quick look inside the design, I am going to incorporate a small loft, sleeping area, maybe a little bit of storage up there. So I want to keep the cabin as open feeling as possible, but can't resist that little bit of extra space. So what looks kind of like a telephone pole here in Fusion 360 will hopefully be a tree trunk that I'm going to find on the property, and something that's probably maybe 10, 12, 14 inches in diameter, and I'll incorporate it both aesthetically, but it's also going to be a structural element. It's going to hold up or help hold up the beam that supports the south side of the roof. It'll help hold up the second or the loft framing, and then probably will be turned into some kind of a ladder or staircase. Not sure exactly what that's going to look like right now, but I think it'll be a cool idea. I've seen a lot of really neat pictures of things like this that people have done in their cabins, so I will use that as an inspiration. I mentioned earlier that the state that I'm building this in has something called a recreational cabin law that exempts or potentially exempts certain structures under 400 square feet from the building code, provided you meet certain criteria. The building code in this state is Uniform Construction Code, and I want to say right here, I'm not an engineer, I'm not an architect, I am not a building code official or inspector, but I am familiar with design, and I have designed structures before that were built to code, approved by engineers, etc. So I don't plan to build this cabin entirely to Uniform Construction Code, because I think that there are a lot of features in that code that don't really apply to a cabin, and something that isn't going to be used for year-round residents, and really it isn't always practical for an off-grid cabin. However, I do intend to stick as closely as I can to the building code for structural elements. And part of the logic to that is that those rules do exist for good reasons, and also because if I were to ever decide to make this something other than a recreational cabin, I'd like to, if I'm going to leave portions of the building code aside, I'd like those to be things that I can fix later. So for instance, if I am not going to wire the cabin to the building code, which would be unnecessary because it's an off-grid cabin and isn't going to have a lot of the features that a normal residential house would, it's also easy to retrofit, or relatively easy to retrofit, whereas retrofitting structural elements later down the road to meet the code would be challenging. So talking just very briefly about a couple of the things in the design that I incorporated to try to meet the code. One of them is what I refer to as braced wall panels. And again, I'm not a building code expert, so don't take what I'm saying as gospel, but to make a complicated story short, there is a requirement for some type of bracing, lateral bracing, or rack bracing on each length of wall that exceeds a certain length. And for this cabin, what that really amounts to is that on each wall, and again, I'm making this, I'm breaking it down as rudimentarily as possible, and I'm leaving out certain exceptions and things like that. But what it means for my purposes is that I need a 4-foot section of each wall that is a braced wall panel to prevent the wall from racking. So there are a lot of ways around that. There are structural exceptions to that. You can incorporate other aspects of the design, but I'm trying to keep this simple. I'm building it myself, and I don't want to go down the road of trying to make it very complicated. So with all that said, when you look at the west wall here, you'll see that the northernmost side of the west wall has a 4-foot section of sheathed wall. So that will be the braced wall panel section. And that essentially allows me to then have windows in the entire rest of the wall while still meeting the code for that structural condition. Looking at the south wall, the same thing. I've got a braced wall panel, a 4-foot braced wall panel in the center, and that meets the requirement for that wall. Now there are some things that have to be addressed, so there has to be a 800-pound minimum hold down here in the corner, but that's something that's easily accomplished, and I'm not concerned. I would do mechanical hold downs all around the building, regardless of whether they were necessary or not. As you can tell from the sketch, this is going to be a pier foundation. For me, with the machinery and tools and time and manpower that I have available, that's the easiest way to do it on this fairly steeply sloping lot. The piers will be built to code with the footings below frost depth and rebar and all that kind of stuff, as well as all the mechanical hold downs that are required by code to join the pier to the post to the foundation. And of course, the lower portion of the foundation will be pressure treated wood to meet the code and also just for good common sense. I also want to say one other thing, which is that for me, having dealt in the past with a lot of critter issues in houses as well as cabins, I'm going to sheathe the entire underside of the floor in 1/2-inch pressure treated sheathing. And I'm going to make it so that there won't be any little holes or cracks or crevices for mice or squirrels or any other critters to get into. That is my personal preference. Personally, I think it's a wise way of approaching it. It cuts out a lot of problems later down the road. Does create a little bit of a challenge from a construction standpoint, because I either have to crawl underneath it after it's built and apply the sheathing, which I don't plan on doing, or come up with a way to apply the sheathing as I'm framing the floor, which is what I intend to do. And presumably there'll be a video someday down the road of how I build this thing. But that's just a few of the sort of structural and code issues that I'm trying to incorporate into the design so that, I'm meeting the intent as well as the safety requirements for things that will be very difficult to change later. Okay, I think this will be kind of the last portion of this video, and I'm just going to talk a little bit about 3D drafting in Fusion 360, neither of which I am an expert on, but just in relation to how I've been working with it on this design. So, 3D design, I hadn't done a lot of it before, but obviously it's just like super cool. I mean, the ability to turn, flip, look at it from different angles, visualize it is worth a lot. It's super helpful. As far as how I use this, there's different approaches to drafting, especially when it comes to structures. I drafted this literally the way that it's going to be built, or the way that I intend to build it. So the elements that you see in the drawing are what will be the elements, the structural elements that are incorporated into the actual building. And that was, that is a tedious process. However, it allows me to work out the construction details as I'm drawing it and not on site, or not as I'm building it and maybe making some mistakes. And I think it's going to save me a lot of time down the road, because I already know in pretty granular detail how I'm going to construct this. And I'll show a little bit of that here in a minute, but Fusion 360, super powerful tool. I'm not an expert on it, but one thing I learned and one thing that I'm incorporating here is that I have grouped the different elements of the structure into, they call them groups. And that is really helpful, because it gives you the ability to turn them on or off, or to select them, and to, whether that's to see other parts of the design, or whether that is to, focus in on how you're going to estimate and count these items. So just as an example, so I'm going to turn off the roof sheathing, the wall sheathing, and the rafters. And this is kind of the view I had before, and actually I'm going to take out the second floor as well, or the loft as well. So I've drawn each individual stud and header as I intend to build them, down to the level of detail of the overlap of the plates and how the corners are going to be built. And then I've grouped those wall assemblies into sections that reflect how I intend to build them. And so I'll give you an example kind of what that looks like. So let me cancel out of that. So that, when I pick, the west wall assembly, which is labeled 2 because it's going to be the second wall assembly that I build, all those pieces are highlighted. So that is literally how I'm going to frame that wall. And I'm doing all of these assemblies in a way to where I know that I can build it myself and stand it up on site relatively easily if I don't have any help at all. And it'll also make it easier when I'm doing the actual construction drawings. But it's a super useful tool to visualize how you want to build the project. And then when it comes to estimating the project, which I haven't done yet, I will be able to go in and literally count the individual studs, the plates, the pieces of roof sheathing, to count exactly what I want to do. I drew the roof sheathing as 4x8s, so I can just simply look at this drawing and say, okay, 1, 2, 3, 4, 5, 6, 7, 8, and then count the little pieces, 9, 10, whatever it's going to be. That's how many sheets of plywood I need. And I can do that on the wall sheathing, the roof sheathing, floor sheathing. And so I'll make a spreadsheet and start counting these things up. So basically what I'm saying is that this tool, specifically Fusion 360 in this case, although I'm sure a lot of the other three-dimensional drafting programs would do the same thing, is going to make the construction and the planning for the construction a great deal easier for me. And since I'm going to be working in a remote location where running out to the store to go grab another 16-foot piece of lumber is going to be time-consuming and problematic, my intention is to order, exactly what I need with some extras, and hopefully not to run out while I'm in the middle of doing this thing, because it's going to be a real drain on my time and efficiency if I'm missing parts and I want to have to go back out and pick something up. So that's just a little bit of discussion about why I have found Fusion 360 to be such a good program for this. Again, I'm sure other three-dimensional programs do the same thing. I'm not an expert on Fusion 360. Just got to say, though, that it's been a really interesting and useful tool for me so far. So I hope you found that video to be useful or interesting, at least. As I said in the beginning, there's a million different ways to do everything. So there's, none of this is intended to be a statement that the way I'm doing it is the right way, or that, someone else, if you built your cabin a different way, you got a shed roof or a gable roof. I mean, I'm not slamming anybody's decisions. This is just my own personal thing. And so I hope that maybe the thought process behind it is of some use to somebody. And, it can be an interesting adventure no matter how it turns out. I do have an Instagram page if you want to check it out. It's Mr_Pitts, P-I-T-Z _. It's got, some other stuff besides this, but I will be showing some pictures of the cabin and the construction as I go along. So that's it. Hope you have a great day. Thanks.